for my company.
Of course.
Yeah. So today that I think a couple of people we are familiar with are missing, like Martin. Yes.
Yeah, I heard that. I saw that.
Yeah. So, and some people probably are also sick. So,
Mhm.
so this is your presentation.
It's the beginning of it. Yeah.
Okay. Wow. You have the konnichiwa. Konnichiwa. You have the and also ni hao and the bonjour. Bonjour. Ah, you don't have the buenos dias.
Oh, I just put hola.
Hola.
Hola it is.
Okay. Wow. This is really thoughtful.
Give it some more
Yeah.
time. Yeah, we got an
Yeah.
international crowd.
Yeah. And because there's some of the people, they already said that they cannot join us and they hope that we can record. Of course, we always record the webinar, but
Mhm.
it's a, I mean, pity they cannot be with us because we are so familiar with them. So it's like, yeah, part of the webinar is missing. No, yeah.
It's okay.
Okay.
We'll get some new faces today.
So see here that we have Henning. Henning,
Hello.
hi.
Hello.
Yeah, what time do you have over there?
Here it's 5 o'clock p.m.
5 o'clock p.m. Okay, that's good.
Not, not
And
bad.
Richard, you are also from Germany, right?
Yes, yes, yes.
Yeah. So Richard and Henning.
Hello, Richard.
Hello, Ricky.
Okay, and Oz Manning. Yeah, he look. Wow, Oz Manning, are you still no on location? Ah, okay. You work for the Manhattan district, right?
Yeah. I think it's on mute.
In the five boroughs. Yes, all throughout the city, but stationed at the RFK Bridge right now.
Okay.
Mhm. Yeah.
And thank you, Osmani. And we have Manny. Manny is from UK.
Tanya.
Yeah, please say hi to everyone.
Hi, everyone.
Hi.
Thanks for joining.
Hi, Tanya. How are you?
Oh, pretty good. Complete.
4 p.m. over here.
Ah, okay. We have 8:02 here, AM.
Yeah.
And I guess that the 33 visual node taker, I think this one is probably Gladius.
Hi,
Okay.
Tanya. Yeah, it's me. I'm just a
Yeah,
little sick, but I'm here.
I see. Oh, sorry to hear that.
Yeah, but
Yeah,
I'll be listening on, and I turn on the note taker because Martin wanted
yeah,
to take to have
yeah,
the summarized version of
yeah.
the webinar.
Okay, so Martin and Avi won't be here with us, and I know that a couple of them won't be with us either because they already left message in our WhatsApp. So we know. So today, the turnout probably will be a little bit low. And let me see who else is here. Let me take a look. Uh, because last time our turnout was pretty good. I think it's like 28 for last time. It's a really good one. And let me see. Ah, we have a Gonzalo here. Okay, Richard. Okay, Michelle. Is it Michelle or Michelle? Gladia. Henny. Okay, Lona. Lona is our operations manager. She is also with us. Okay, Stephen. Where's Stephen? Hi, Stephen. Okay. Oh, Yanev. Yanev is new with us, if I'm not mistaken. Okay, Tito. Okay,
Yeah,
so
sorry about that. I'm in mute. I'm on my bicycle.
I know. I saw you on your bike.
you have that gear like that you are in battle. Okay, so Gabriel?
Hmm.
Yeah, so do you want to introduce yourself to us? Let's
Sure,
start.
sure.
Yeah, yeah. Please give
Absolutely.
us a brief intro. Thank you.
Okay, guys. Well, thanks for joining the webinar. My name is Gabriel Alaka, and I am an architect that's based in Los Angeles, California. I've lived in several countries throughout my life. I'm married, I have one son. I graduated from Woodbury University in 2007 with a bachelor's degree in architecture, and I've been licensed in the state of California since 2018. I'm currently a project architect and a BIM manager at a place called Wet Design, located in Los Angeles. I specialize in water features, and I also started a side hustle, kind of a business earlier this year, which is called G Alaka Architects, which is essentially my name, Gabriel Alaka Architects. Um, and I've been in the AEC industry for over 20 years. And AEC stands for Architecture, Engineering, and Construction, for those of you who don't know. You're more than welcome to visit my website to take a look at my portfolio. You can also contact me directly through the website. Before I start the presentation, just wanted to give you guys a few side notes. So all the slides that I'm going to be showing right now, and I've also prepared some step-by-step instructions about what I'm going to talk about later on. I can send that to you free of charge. All I ask of you is just to send me an email to Gabriel@galacarchitects.com, and I will just send you these PDFs as soon as I get your email today, or whenever you're watching this recording. You can also send me a message through my website or send me an email. Throughout this presentation, feel free to interrupt me, ask me questions as I go. There's no need to wait till the very end. When I work on architectural software, sometimes I tend to go really fast. So if need be, ask me to slow down and I can repeat what I just did. Just a big note, this is not a Revit tutorial that could take hours, days, months. However, just to let you know, the Revit template or the Revit interface I'm going to be showing you is not something that's out of the box. It's my own personally designed Revit template that I actually offer for sale. If you are interested in getting that, also hit me up and we can talk about that. My experience in the three softwares I'm going to be talking to you today are as such. So when it comes to Revit, I've been using Revit since 2009. So every single iteration that's come out ever since then I've been using. So that's about 16 years. However, when it comes to Cloud Compare and Autodesk Recap, I'm fairly fresh at those because I've just entered the point cloud market about 6 months ago. So I have less than 6 months experience in those two softwares. However, I'm able to use them to, I know what to do in those to get what I need. And that's what I'm going to be showing you today. Point clouds could also be imported into AutoCAD. However, at this point, I don't really use AutoCAD for any three-dimensional work. Some people do. If that's your thing, I believe what I'm going to show you today will also apply to AutoCAD. However, today I'm going to be showing you how to use point clouds in Revit. Another thing is I am not going to be going over the Realsee scanning process, as that was essentially covered by James Heck about a month ago during his webinar. Again, when I send you this PDF, you can click over here to watch his own webinar. This tutorial assumes that you've basically already scanned your project and you've downloaded the e57 file from the Realsee console. So that's the assumption I'm getting. You already have that file downloaded, and we can kind of start from there. One thing to point out is that there's nothing really automatic about the as-built documentation process in Revit, and it is a time-consuming process or a venture. And even within the WhatsApp community on Realsee, there's a whole bunch of people who specialize in this kind of work. So it's something that people do out there because there's a high demand for essentially getting as-built conditions. So there's a lot of people who do some really, really good work. that you can see within the WhatsApp group. So I'm not the only one that does this, but I'm just going to show you how I do it. Everyone's got their own process, but hopefully everyone can learn a little something from today. I'm going to be going over 2 scans today. One of them is going to be a full house residential project that the outside and inside were scanned. And then the other one is going to be a completely empty lot. And again, there's hyperlinks here just to kind of show you what those look like. The first one is going to look like this. This is the first scan that I'm going to be showing you. It's a rectangular lot in Los Angeles, and it looks something like this. So you're going to be seeing this facade quite a bit today. And then the other one I'm going to be showing you is essentially this one, which is a completely blank lot from Altadena. This is one of the sites that was affected by the California fires earlier this January, and they've ever since cleaned out the site. The reason why I'm going to be showing you this particular site is because it is not flat. It looks flat, but it's not flat. The road actually slopes down here. Then on the actual site itself, if I kind of pan around, you're going to see that it slopes up here. There's a big hole in the middle. So essentially, this is a very complicated site, not to mention that it's also in a corner. So I'm going to be showing you this scan as far as how to generate topography out of this. That way we know the high spots, the low spots, and how I'm able to use the Realsee point cloud scan to generate topography out of this model. Just a little bit about my setup. So typically, for those of you who already have the Galois camera, this is what comes out of the box. You get the backpack, the tripod, the battery, the actual camera itself, cables, such and such. The only things I had to get in addition to this are this little tripod dolly that you see at the bottom that kind of locks it into place.
Oh.
And I've included a link to what that is. And I also purchased what is this thing called? The little holder from my iPad. That way you can just kind of hang off your neck. So those are the only 2 things extra that I had to get. Another thing that I've invested in is this really tall extension. It adds an extra meter to the existing Realsee tripod. And it kind of it helps sometimes if you want to document something a little bit higher. It also helps with the pitch of the roof in some instances. Also, one thing to mention is when I do my scans, I don't necessarily do the ultra high resolution one. In my opinion, I'd rather do additional scans than make longer scans, if that makes any sense. So sometimes it's actually okay to do a scan in one spot and then lift the tripod higher, do another scan, move it a little bit left, move it a little bit right. But it's better to get a lot of scans because that gives you a lot more point cloud data down the line.
Makes sense.
If you do decide to get this extension, you also have to get a little adapter because like a little tripod adapter. That way the male, the female works at the very top. So I can use the existing this little snap over here.
Gabriel, does it really hold? Is this dirty? Because if you have strong gust, and that would be broken.
It shakes a little bit. I have to admit, when I take it all the way up, it shakes a little bit. So you have to kind of find a sweet spot where it's not too tall and it can still be okay. But obviously, if you have a little bit of an incline, it gets a little dangerous. So use at your own discretion, so to speak. For me, it was fine. And obviously, when I'm doing this, I'm standing right next to it in case something happens, and I'm walking around it. If it wants to tip over. But if you hold the bottom and kind of walk around it, it actually works pretty good in that sense. But this is not something I use all the time. I mean, for the most part, it's a lot lower, just the way it was designed with the tripod. But at this extension all the way up, it does shake a little bit, just a little bit, but it still works.
Thanks for sharing.
So my main objectives for today is to show you how to optimize the e57 files from Realsee using Cloud Compare. The main reason for this is because for those of you who have been using Recap, all it takes is one error message, one force quit, one crash, and then Recap just starts just misbehaving. And I've gotten to the point where Recap is a little bit useless for me because I can no longer export from Recap. All I can do is import and save.
Oh,
And
yeah,
I've,
I
I've
remember.
tried I've tried upgrading, I've tried uninstalling. Recap is just one of those softwares that once it goes wrong, it just stays that way. So hopefully
Yeah.
Autodesk will fix that
Yeah, I
down the
remember
line.
one of our users, in WhatsApp group, and he used a recap. Remember that
Yes,
he was so frustrated with,
frustrated. Yes,
yeah, and then he keeps saying that what's wrong with the point cloud, and he
yes.
there's something wrong with our point cloud instead of recap, and
It's
he
recap. Yeah,
yeah,
the issue is recap. It has nothing to do with the point cloud. So I'll show you essentially how to optimize the E57 file in Cloud Compare and then bring it into recap, and it'll save you tons and tons of time.
okay, thank you.
And then I'm also going to show you how to extract or how to separate the ground plane from the building in Cloud Compare. That way you can generate topography in Revit or any other software, as a matter of fact. I'm going to show you how to clean up a point cloud in Cloud Compare, which is not at least for me, it's not a very user-friendly interface, but it works. The one that does have a very nice interface is Recap. It has a very nice way of kind of cleaning up the point cloud, even though it's a little bit manual. However, Cloud Compare has a lot more buttons and things that you can do to manipulate a point cloud. While Recap, it just looks prettier. It has a lot less things that you can do, but it's a little bit more user friendly. I mean, in a perfect world, something would exist that kind of combines both of those together. And I think that's what was shared. I forgot the gentleman's name when James had his webinar. That there was a guy that was showing.
Oh, from you mean from Applet top?
Yes, that's the one. Yeah.
Yeah,
So they had
yeah,
they had a software which I'm assuming is what kind of merges these two together.
yeah.
But I haven't really messed with that software. For now, I'm using these two. But yeah, there's other options out there.
I see.
And then I'm also going to show you, essentially the workflow of a point cloud in Revit and a brief look at my template. So long story short, I'm going to be showing you how we can take a point cloud that looks something like this from Realsee, and then this is a composite image of the same view with geometry kind of drawn over it, and then the end result is going to look something like this.
Ah,
Okay, so to start, so as I said, so my assumption is that you've already downloaded the E57 file from Realsee.
mm-hmm.
There you have the option of I think it's a PLY or E57. For the purposes of this, you want to download the E57. If you accidentally download the PLY, you could use Cloud Compare to convert that to an E57, but ultimately you need the E57 file.
Mm-hmm.
And as you can see, what we get from Realsee is a file that's a little bit under 3 gigabytes. And this E57 contains a lot of data, including the actual images as well. So the first thing that needs to be done is we need to optimize this file and also combine all the scans, because this file that comes from Realsee has as many scans as you did. So in this case, I did like 80 something scans. So this file contains 80 something scans. So let me just show you real quick how to optimize that. So the first thing you're going to do is you're going to launch Cloud Compare. And just so you guys, I kind of stated this earlier, but I have a little tutorial, like a presentation of like all the steps I'm going to show you right now. So if you want this file, just send me an email and I can send this to you with all these little step-by-step instructions. So once you launch Cloud, you're going to go to File, Open, and we wait. Of course, it's going to be all slow on me. The one day I need to use this.
So this is in the
Come on.
cloud compare environment.
Yeah, so now I'm in the Cloud Compare
The,
interface, and I have downloaded the e57 file.
so was this that what you taught before? You said you was an instructor for that.
Yeah, while I was at school,
Oh,
I did tutoring and some mentorship. So I'm pretty used to, I guess, teaching software. See, now it wants to crash on me. Technical difficulties. This is very unusual. Okay, let's try this again. Cloud Compare. Okay. All I'm doing is file open. There you go. So I'm gonna go to, for example, let's do the one that's the actual house itself. So once I open up the e57 file, you're gonna see that. So in this case, it was 83 scans. So right now it's loading every single scan into Cloud Compare. So just for the sake of this, I'm gonna do this live so that way you can see that it doesn't take that long. And by the way, Cloud Compare is an open source software. It's completely free. And I want to say it's also available for Mac from what I see on their website.
mhm.
However, Revit is only used on PC. And I want to say the same thing goes for Recap. That is also on PC. So you want to stick with PC for everything.
Mm.
Okay, so now it's loading this.
I've been using Cloud Compare on the Mac, and it's pretty good.
This pretty good. Okay, yeah.
Oh,
Yeah, it's comparable. It has all the same plugins
Yeah.
as
Good.
as the Windows. Yeah.
That's
okay.
good to know. It's good to
Good.
know.
Good. I'll give it a try with my MacBook.
Okay, it's almost done. So right now, the reason why it's taking so long is because it's actually loading the images as well.
Mm.
But once it's loaded, it's in. So we're almost there.
Hmm.
There it is. So now I'm in the Cloud Compare interface, and there's my entire scan. So the way Cloud Compare works is that it kind of gives you this little tree on the left side. So every single one of these things is a scan. Every single one of these. And within each scan, there's also going to be there's this thing called TLS GBL, and there's also this image. So if I click this, you're going to see the entire image show up immediately.
So what is the TLS GBO?
I think it's a location tag.
Oh,
It's a little location tag. So there's basically like where the scan was taken.
so that is
It,
kind
it,
of geolocation
yeah,
indication of
exactly.
geolocation.
Geolocation and then image.
I
So
see.
that's what, and then everything got stitched together. So the first thing that we're gonna do is we're gonna essentially click on all the scans on the left side, highlight everything, and then we're gonna go to edit and then merge. And then when you get the screen, you want to select no. It says, do you want to generate a scalar field? If you click yes, you lose all the colors. Everything becomes a rainbow. So you want to say no to this message. And now what happened is, and now it just essentially it merged all the scans into one. It just kind of, it did that. After you do this, you can rename this to whatever you want. So I'll just call this, main house or something like that. After you do this, you want to click on this little checkbox and then select all of the TLS points and all the images in the tree below, with the exception of this one, because this is your point cloud. So you want to select everything but that last number and just basically delete.
No, bigyan dulu.
And it still stays.
No.
Is someone asking something or someone just unmuted themselves? Okay. So now, as you can see, so now at this point, we removed all the images in the file, and all we're left with, oh, there's one more. Sorry, I guess everything is to get deleted. So this main one is the point cloud itself, so, which is still in the image itself. One thing I've started to realize is that I don't know why this happens on most of my scans, but every single point that I scan kind of shoots off this beam, this LiDAR beam up into the sky. So there's definitely some cleanup that needs to happen. There is a way, like an automatic way in Cloud Compare to kind of clean that up. And then for that, I'm going to click on, it's a plugin, and it's called, oh, sorry, Tools Clean SOR Filter. And I don't really mess with these settings, but once I hit OK, it'll kind of process this, and it'll get rid of a lot of noise or whatever it can, like in an automatic fashion. But if you wanted to, you could actually sit there and try and clean this up yourself, piece by piece. But this is just the quickest way to just erase all of that noise in one shot. So let's wait for this.
So the plugin is also part of the Cloud Compare?
Yes, yes. Well, once you download Cloud Compare, you have all this already included.
Mm.
Come on, come on. This is the part that probably takes the longest, because we're actually sitting here and waiting. But it's better to do this here than to do this in Recap, because Recap could take, forever, days. Who knows? Okay, so it's almost done. And then, so now the way Cloud Compare works is that every time you manipulate the cloud, it kind of creates a new cloud underneath it. So you're gonna see, so right now what it did is, so it still retained the old one, and whatever I just did, it created a new one, and then sometimes it'll give it a new name. So as you can see, a lot of the noise kind of got erased automatically, but it kind of kept a lot of what was there before. And it just gave it a new name. So this is almost the way. One thing about Cloud Compare is that there is no undo button. Like, you cannot undo. So one thing I like to do is, if you want to save your Cloud Compare file, you want to go to Save Project, but the Save button is more of an export button. So for example, if I was satisfied with this point cloud and I wanted to save this as an optimized version, I would select the point cloud here, and then the save button is going to essentially save the entity, not the whole screen. Like, it's not going to save the Cloud Compare project. Once I click on save, this is now where I'm going to go to, let me go, where is it? And now I want to show you how long it takes. So this is my optimized file. Yeah, I'll just call it main house, whatever. I'll hit save. So there it is. So I took a file that was 2.6 gigs, and I just saved it as an optimized version that's 371 megabytes, and it's just one scan. It took 82 scans, combined them into one, stripped away all the images, and I'm only left with the point cloud itself, which is what I want. And just to note, this cleaned up version of the point cloud has 14 million points. You can kind of see it over here on the left side, or you can right click and say information, and it will say, 14 million points. And now, really quickly, I'm going to show you how this looks like in Revit before I go any further. So now in Revit, and again, this is my own template. I'm going to go to a particular view, and in Revit, I'm going to go to Insert, Point Cloud. I'm going to look for that. Oh, actually, wait, I can't. I need to go in Recap first. So let me go to Recap. So now I need to use Recap to turn the e57 file to a RCS file, because that's what RCP file, because that's what Revit wants. So now in recap, you're going to click on new project. And then you're going to say import from cloud. So the first thing it's going to ask you is to name your project and also give it a destination. So I'm going to just call this main house as my project name, and I'm going to give it a destination. Wow, why is my browser like tripping out on me today? It's just something so simple. It's like my Windows is not happy today. This shouldn't take this long. Oh, there you go. Okay, so I'm gonna go to, I'll just put it here. I just picked a random folder. And so the name that you're gonna put here is gonna be the name of your actual RCP file. So, and once you name this, you don't really want to rename it. I'm gonna proceed. And now it's asking me to drop that e57. So I'm gonna find that optimized e57 file, and I'm gonna just I can do a, click the plus sign, or I can just drag this here. And then you're gonna get this screen. You're gonna just click on import files. Now here's the screen that most people get hung up on. If you use the original file from Realsee, you're gonna get a bunch of circles, and it's gonna have to process every single one after the other, after the other, after the other. So your screen could be completely full of circles, but because we combine everything into one, you're only gonna get one of these circles to kind of process over here. And this is what will save you a ton of time. So here it is, it's almost done. A little bit longer. We're gonna wait. There you go. Okay, finished. And then we're gonna say index scan. And then once this turns blue, you say launch project. There it is. Now the scan is in recap. And at this point, I could just I could just close it. Close and save. Close and save. And just to show you what that created, if I go to the folder, so there it is. I called it main house. So it made a file called mainhouse.rcp, and it also created a support folder. So these two work together. And this file is looking for this file. The main house became 1.2 megabytes, and then the support file is 310 megabytes, but they kind of like rely on each other. This is Revit's way of extremely optimizing that point cloud to make it into even a smaller file. So now we've turned almost a 3 gigabyte file to 1.2 megabytes. Okay, now we can go into Revit. So now in Revit, we're going to go to Insert Point Cloud, and there it is, Main House RCP. And I'll just say an origin to origin, center to center. At this point, doesn't matter. And let's see how long it takes to come in. There it is. It's already in Revit. There's the project in Revit, the whole point cloud. And this is really easy to move around. As you can see, I can jump around as much as I need. Before I go into the next steps, I want to show you how Revit can display the. So within the visibility graphics of the point cloud, right now it's set to RGB mode, but it also has these other settings, single color, which I don't understand why this exists, but it'll just turn everything one color. I don't really know when anyone would ever use this. Another way to view that is by intensity or elevation. Elevation just basically means the highest point is going to be red, the lowest point is going to be blue, or whatever you want. So in this particular case, all those trees on top are going to be red, gradient. So everything up on top is red, and then everything is more blue towards the bottom. However, the only useful one, in my opinion, is obviously RGB or normals. what normals does is Revit will try to identify like top plane. So as you can say, any plane that it's considered the top is green. Any plane that's considered this side is red. If that kind of makes sense, it kind of tries its best to identify certain planes. So this is really the only one that becomes useful at some points is this one. However, for the most part, I mean, I honestly just stick to just RGB. That's the only one that this is, the actual true colors of the scan itself. And then in Revit, what I'm going to do at this point is I need to place this on the side. One thing you're going to want to do is, draw your property line and then kind of place the house where you think it belongs. And then you can actually cut some slices through it. And you can kind of see here. So I'm going to go to a cross section and I'm going to move this to where I want it to be. Now, the beauty of Revit is that you're able to view a point cloud as a very thin slice. So in this particular case, I don't know if you can see here, in my section cut, it's cutting at a certain location, but it's only seeing like this deep. If I made it deeper, then I would see a lot more point cloud information. However, since I want to see just a little slice of my point cloud, I make this extremely thin. So then when I go to my view, I'm looking at a very thin slice of that point cloud, which this helps me to determine in this case. Let me move this to a different spot. I'm gonna put this right here so I can figure out the levels of the house. So I can already tell here. So this is my living room. I'm gonna place this approximately there, and then my ceiling is over here. I'm very rough about it. So now this tells me this house has an 8'3" ceiling. And then the same thing goes for plan view. So if I go to a plan view, this particular plan view, in Revit, you have the option, you have a view range. So right now, this view is cut 4 feet above the first floor, and I'm only seeing 6 inches below and 6 inches above. So I'm essentially viewing a very, very thin slice of the point cloud. Because if I was to make this, I don't know, negative 10 feet, this becomes very hard to understand. Like you have no idea what to document because there's basically too much information being shown. However, if you look at the model as a very, very thin slice, you can start to identify, this is pretty much a wall. That's a wall, that's a window. It kind of starts to make sense based on the point cloud information. And any kinks in the wall are very easy to identify. And essentially, based on this, you can just start drawing walls. So, here's a wall. I'm gonna just pick a random wall, an exterior wall with stucco, and I'm just gonna draw a wall right here. Here, and then it turns here, and I can move things around. And then I know for a fact that, there's a window somewhere in this location, roughly. And that's why I say this is this could be a very time-consuming process. I'll take this here. I'll place it in front of this window, make it a little bit deeper. So now I'm going to switch to this view for a second. So there's that wall that I just drew on top of here, and I'm trying to put a window in it. So one thing you can do in Revit is that you can set transparencies to certain model elements. So now I can kind of see the rough outline of the window. So if you guys can see it, sometimes the thing with the point clouds is the more you zoom out, the better you see. When you start zooming in too much, everything starts to look the same. So I can kind of tell that the window sill is like here somewhere, and then it kind of goes up to here. Here's my left side. Here's my right side. And then if I go back to place a window, I'll just pick, something like this. And voila, there's my window. And then when I go back to my floor plan, I've just drawn a wall and I've placed a window based on the point cloud information. And at this point, all my model contains is just those three walls.
Hmm.
It's just to kind of show you how it works. So I drew this and I placed the window on the inside. And then you can just keep repeating this over and over again. So as you're building this model, you just keep moving these section cuts, around until, you draw all your walls, you put all your windows, you cut them, you slice them, you look at the elevations. And then what's even more useful is if you had two screens and then you have your Realsee 3D tour on one side, you can actually look at the actual house or whatever you scan and essentially see it in real life and then document over here on the screen. And, I'm not going to keep doing the whole house, but you kind of get the idea of how this works. And again, this is not Revit out of the box. This is my own template. So everything looks the way I want it to look like. And this is tailored especially for residential projects.
Hmm.
Any questions on Revit and point clouds before I move on to topography? Because I only have 20 minutes left.
Any question here, guys?
Yes.
Mhm.
Can you regard to the size or can you show how you can measure the size of the wall and that you scan already?
To measure, well, everything came in at full scale. I'm looking at a full scale model. Everything is exactly, so this property line right now is 75 feet. So I'm literally looking at the model. So anything that I draw, I mean, this is Revit, so I can draw a line, I can do a measurement here. In Revit, there's a measurement tool, a measure between two references. And anywhere that I click on, you can kind of see the dimension on the screen. You see it? Where it says 11 feet.
Yes.
Yeah. Everything here is in complete 100% full scale.
Hmm.
The point cloud
Okay.
comes in at 1-to-1 scale.
And can I export it as OBJ or FBX file?
From the point cloud itself, you mean?
Yes.
The point cloud. Let me see what your options are here. So if I was to
You mean
save
you know I need to scan this kind of area and take it to Unity
here
or
it
to
is.
Unreal
Here it is.
and
From
okay and can I
Cloud Compare.
manipulate sorry can I manipulate the object inside the area or to move the wall or
No.
to no.
I mean, depends. I mean, from here you can extract it as an OBJ file from what I'm seeing from Cloud Compare. When you save the entity, you have the option
Mm-hmm.
of there it says OBJ cloud or mesh. So
Okay.
you can give this a try. I'm not sure how it's gonna show up on your end. Maybe you can manipulate it, but I don't know how it's gonna come out as an OBJ file. But for what I'm showing right now, the point cloud is just there for a reference. I don't really manipulate it whatsoever. I just use it as a guide to kind of trace over.
Okay.
But yeah,
Okay.
you have all these different options of what you can. So you could definitely do an OBJ cloud or mesh. That's for sure.
Okay. Thank you.
Mm-hmm. Okay, so let's move on to the other one. Guess I'll just close this and make a new one. Okay, so now I'm gonna bring in the other file. So I'm gonna open up the one that's already been optimized, so I don't have to repeat that whole process all over again.
Mm-hmm.
If this decides to work. And of course, this is the first time it's ever done this. I don't know why it's taking such a long time just to do file open.
Because we are watching.
Because you're watching, exactly. Let me just, yeah, this should not take that long. Okay, let's try this again. Second time's a charm. Okay, so file, open. Oh, goodness. I need this thing to open. while this is opening or trying to open. Any more questions about Revit?
Hi, Gabriel. I do have a question regarding the scanning. Do you need any targets? How does Cloud Compare put all the scans together?
Oh,
Before
that's Realsee. That's not me.
Oh, okay.
Yeah, that's how it came in.
It's just automatically.
That's all done. That's all done by their own interface from their own AI. So one thing I noticed, especially on this project, the one that was the lot. I'm gonna just open up this one real quick. So this particular one, I was actually worried that I might need to do a bunch of as you say, those little what you call them, the tags.
Yeah, targets.
The targets, yeah. So I was able to scan this, empty site that was basically just dirt everywhere without using a single target of any kind. I didn't use those alpha things, or no, what are they called? April tags.
April, yeah.
Not a single April tag was used here. And in some cases, my tripod wasn't even flat. It was like at an angle. So Realsee was able to like rotate and position each point compared to the next one. Because in some instances the tripod was not exactly level whatsoever. Like I could visually see that my camera was facing down or facing up, and it was able to stitch everything together.
Oh,
Oh,
good
nice.
to know that.
And of the 3 scan settings, which one did you use for this project?
Just
He
the basic regular one.
Yeah, he just
Regular.
used
Standard?
Yeah, he said he took more points instead of
More points instead of longer ones.
Right,
Okay.
Yeah,
right.
more points
Understood.
instead of longer ones. So
What kind of tolerances have you been averaging like across your projects when you do these as built? So like existing conditions, like you're within
like, I don't know, an eighth of an inch maybe.
an eighth of an inch.
It's pretty accurate. So the way to test that is to take the longest measurement you possibly can and then test it out in your scan afterwards. So take a measurement of like, more than 30, 40 feet somewhere and then just see how close it is. It's almost near perfect in that sense. Okay. So I'm gonna just quickly clean this point cloud up, and then I'll show you the next step. Okay, so there it is. So now I've roughly cleaned this up. So now there's another tool here called the CSF filter. What a CSF filter does is it'll try its best to separate the ground points from everything above. And that is a plugin called, if you select the point cloud on the left in the selection tree and go to plugin and hit CSF filter, the first thing it's going to ask you is what kind of site is this? Is it a flat site? Is it a slight relief or a steep slope? So in this case, it's, I guess, this middle one. You want to click on slope processing, and then over here, I tend to keep this at 1. Everyone can just keep messing with these settings. I keep this at 1, I keep that at 500, and I keep that at 0.5, and I just hit OK. And now what this does, it created a new point cloud here with 2 objects. There's ground points and then there's off ground points. So it removed everything above the ground on its own layer, and everything else we kept below. So this is a really nice way to just separate those 2 from each other. Now, the next step is to make this point cloud, which is right now, let me see how many points there are. There are 7.8 million points in this point cloud. Revit is not going to accept 7.8 million points to create topography. That's insane. So what needs to be done is we need to simplify this. So there's another tool, which is called this one over here. It's called subsample a point cloud. When you select this tool, I want you to imagine if you use the spatial one, what spatial does is it's almost like you're dropping a towel over this, and you want Cloud Compare to place a point on a grid every so often. And this number here is in meters. So if I was to click on 1 for my minimum space between points, I'm asking Cloud Compare to give me a grid of this exact same surface at 1 meter intervals. So when I hit OK, it's going to create another sub point. I don't know if you guys can see it on the screen, but if I make these a little bit fatter, where's the, there, if I make, is it this one? Points. It's interesting. It's not letting me make them a little bit more visible. Can you guys see them on the screen? The little points?
Yeah, there's a little point,
They're
but
little dots on the screen.
yeah,
There should be a way for me to like
almost
make them
invisible.
more intense, but they're there.
Yeah.
You might not be able to see them, but there's a bunch of little dots on the screen that basically like they represent. I was just doing this the other day. Like there's a points. So now we made 14 million or whatever into 2,566 points. Is it this one? No, global scale. Draw length. Oh, they're point size. If I make this like this, you'll see a little bit better. Sorry. Hold on, let me do that again. Oh, there it is. There it is. Now you can see it a little better. It basically created a bunch of, a lot less points of that exact same field. Revit can handle up to 10,000 points. So maybe I want to make it a little bit more fine. So I'm going to go back to this one, not this one, this one. I'm going to subsample it. Let's make it every, I don't know, I'll make it every 16 inches or 0.4 meters or 400 millimeters. And I'll say, okay. So now here it is now. Now, as you can see, it's a little more fine. Point size 3. Can you guys see it a little better now? So now it took that massive point cloud and made it into just less points. So now this particular file has 13,908. That's too much. So I'm gonna go back to this one. I'm gonna subsample it. I'm gonna increase it. I'll make it half a meter. Let's do that. I'll do 0.5. There it is. Now 0.5. This has 9,241 points. Perfect. And again, just to kind of show you guys visually, point size, it really like simplified it. So now what we're gonna do here is we're gonna export these points as a text file. And each text is each point is gonna have an X, Y, and Z height. So we're gonna click on this and we're gonna say save. And then I'm gonna go to find a place they want to put this in. And you're gonna save this as it's called an ASYS Cloud text ASV, this one right here. And I'm just gonna call this main points. I don't know, doesn't matter. It doesn't matter what the name is as long as you name it something. And then you're gonna, on this screen, it's very important that you change the separator from space to comma. If you don't do this, Revit cannot read that file. So it needs to have commas. And then you're gonna hit OK. And let me just show you what that file looks like. So that file that I just created, it just looks like this. It's just a bunch of numbers. They just go on and on and on and on. There's 9,000 whatever numbers. And each one has an X, Y, and Z. So now in Revit, your 3D view, I'm gonna hide this point cloud for a second so I can show you what this is gonna end up looking like. I'm gonna go to massing, topo surface. And then I'm gonna go to create from import, and I'm gonna specify a points file. Now by default, Revit is looking for a CSV file, but in our case, I created a TXT file. And there it is, main points.txt. Once I hit open, it's gonna ask me for the units. Just to note, it's in meters. Realsee, their scan, their default settings of their scan is in metric units. So make sure this says meters, and then you're gonna hit OK, and then you're gonna get a bunch of points are gonna show up on the screen. There it is. Look at all those points showed up all of a sudden. And every single one of these points is, at a different elevation. This one happens to be at negative 10 feet. Imagine having to do this one by one, but it basically created a grid of points that are about half a meter apart. And then I'm gonna close the command, and just like that, I have topography. And then if I go back to my section, let's say I'm gonna raise this up a little bit. I don't know. Actually, doesn't matter what I do with it. If I go to a plan view, just turn off the point cloud. As I was mentioning earlier, this is real topography. So if I do some contours, you can see it goes from 4 feet, 3 feet, 2 feet, 1 foot, 0 foot, 1 foot, negative 3 foot, so on and so forth. And then when you cut this in Revit, it appears like actual topography. So there's an actual cut plane that you're cutting through. So when you start placing your house or whatever you're designing on the site, you can start to understand the topography underneath. So that way you can adjust your heights up and down to make everything work. And it's fully adjustable. I mean, after this, if I wanted to, I can still manipulate the point cloud, because all it did is just create a bunch of points for me. I mean, if I wanted to get rid of this pool, all I have to do is just delete all these points. If I delete all these points, I no longer have a pool. There, it just pool's gone. Does that make sense?
Does it make sense, guys? One thing I don't understand that if the area is really big, and you said they only can accept what, less than 10,000.
10,000, yes.
But what if the area is so big and they still have to?
So for that, it would not be topography. It'll be a different entity. So if you have a really, really big area, what I would suggest doing is, instead of exporting this as in this process here, where I did the subsampling, I would have done this instead. I would have gone to plugins, CSF filter, and this time I would have clicked on this export cloth mesh. What this will do is, in addition to splitting the ground and the floor, it'll also create a mesh for me like this. It'll create this, which then this could be exported as just a surface that could be manipulated, but it's not points. This I wouldn't call this topography. But I mean, Revit could handle more than 10,000. It's just that, unless you have a really good computer, it can handle more than that. It will, even if you throw 100,000 at it, it'll do its best to calculate those points. It just becomes too heavy at that point. Like typically when we do topography at that scale, you don't want to make it that big. That's too many points. Because you're dealing with actual, it's trying its best to generate topography, and 10,000 is like the sweet spot in that sense. But anything bigger than that, just export of like an actual mesh. And then this mesh could be exported as an OBJ file, as a cloth, a FBX mesh, a DXF file, for AutoCAD and things like that, for like DWG and things like that. But yeah, but if you want to get native Revit topography that you can actually manipulate, then I would suggest sticking to 10,000.
Oh, and by the way, that for your work, isn't there any what we call one stop shop for all these? You have to go to Revit, you have to go to Cloud Compare, maybe you also go to Recap. So there is no one-stop shop for this.
No, I mean, the only thing I can think about is that software that was talked about during James's webinar.
Oh, okay.
That kind of combines those two a little bit.
I see.
But it's all because it's mainly because when it comes to point clouds,
Yeah.
Revit is only going to accept an RCP or an RCS, and the RCP is Recap Pro, so they've kept it very proprietary to Autodesk products, and RCS is Recap Scan.
Hmm.
So they've made it so that way you cannot import an e57 file, and this all has to do with optimization because you are, after all, trying to take a file that has millions of points and bring them into a software without it crashing. And by them using RCP files, it makes the process very, very smooth because that point cloud becomes like an object that you can really, you can move around easily, and it does not slow down your process whatsoever.
Okay. What do you think that
I've-
we invite, Apple Top, I mean, the CEO, Francisco, come to our webinar and introduce their software to us?
Yeah, that'd be great. Yeah, I mean, I'd like to see a rundown because on that particular software, they were showing how you can, as I said, I think that one looked to me, it looked like it combines Recap with Cloud Compare into one interface.
Yeah, they have,
Maybe it's
as I know, they have more than 30,000 users worldwide.
That's good.
Okay, I'll have a talk with him. Yeah, Osmani, do you have any question?
No, just a comment. I've been using Cloud Compare and exporting straight into Rhino 8 as an E57 file, and it works really well together
Right.
with no need to convert it to another format. Yeah, Cloud Compare is a great software and it's free. So I'm quite surprised as to how feature rich it is.
Yeah, yeah.
Yeah,
I was gonna
yeah, it's yeah.
I was gonna really quickly show you guys how to, I guess, remove points from a point cloud that you don't want. And the I kind of mentioned earlier that Recap has a much better tool to do that. So what I'm gonna do real quick is I'm gonna just, let's say I want to delete these trees up here. So when you pick all these points, you're gonna click on region and then do a new region, and I'll just say, off or something like that. And then over here in your layers, you can basically toggle that off. So you can kind of manually select points and place them on a region, and it'll little by little just start deleting. It looks like I'm deleting, but I'm just moving them to a different place. But by doing this, the file starts to grow.
Hmm.
As you can see, I'm gonna just erase a bunch of stuff that I don't want, and so on. But this is a very manual process, and I'm sure there's some tools out there that kind of simplify this process because this could take you like days, hours.
Yeah.
I can turn off perspective. I can go to a different view. Turn off a bunch of stuff like that. You get the idea.
Okay. Thank you for sharing all you know about platforms. Really, 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 really instructive.
Thank you guys. So yeah, as I said, if you want me to send you these PDFs, just send me a quick email and I'll shoot those back to you. And if you're interested in the template, we can also talk about that further.
Okay. Yeah. Thank you, Gabriel. Any,
Thank you.
do you still have any questions for Gabriel, guys? Any?
Not by now. Just very impressive about all these informations.
Yeah.
Thank
Yeah.
you. Thank you.
I learned a lot. Yeah, thank you, Gabriel. And by the way, guys, that our next webinar will be on July 16. And the topic basically will be about that if you start a new business as a 3D tour photographer, what you should do about it. So that topic is totally different from this. And so far I still don't know that who will be the host for that and who will be looking for that one. So thank you guys joining us today, and until then, happy scanning and take care.
Thank you,
Thank
guys.
you. Thank you,
Bye-bye.
Gabriel.
Thank you. Have a
Thank you.
nice evening.
Bye.
Bye.
Thank you.
Bye, guys.